Okay, thank you so much for being with us today. It's truly an honor to have you here and AstroTeach.
Thank you very much for the invitation. I'm very happy to be with you. So my name is Nidhal Guessoum. I am
Mhm.
from Algeria. I have lived in the Gulf, in the UAE for about 25 years now. Before that, in Kuwait for about 5 years. I did my studies mostly in the US between master's degree and PhD and postdoc. I had also spent several years during my education time between Algeria, my home country, and France, and I have done research and collaborations and lecturing around the world, from Japan all the way to Brazil. I am very passionate about science education, in particular for students at university, in high schools, where I give lectures from time to time, and to the general public, where I have written hundreds of general articles, and I have published also hundreds of videos, mostly in Arabic, but also in other languages, to try to explain ideas, concepts, how science works, what we should know, how it has transformed our thinking, our philosophy, our history, our education. So, in a nutshell, I love astronomy and astrophysics, but more generally science as well, and I am passionate about education. So my work generally can be considered as part of what is known as high energy astrophysics. So I do gamma ray astrophysics. Now this gamma ray astrophysics is concerned with very high energy photons. And these high energy photons mean that we are dealing with conditions in the universe that are extremely energetic, extremely powerful. And that means we are talking about explosions, big explosions, or we are talking with very high gravity fields, such as the environments of black holes, neutron stars, white dwarfs, objects of this kind. And sometimes this happens also on the surface of our sun, where on our sun the magnetic field sometimes becomes completely intertwined or intertwingled, and then there is a breakup and there is a sudden release of energy. So we receive some gamma rays or some X-rays even from the surface of the sun, but this is transient, this is sporadic, only from time to time. But some other places in the universe, we have found repeated phenomena like this. So my field is concerned with these things. And I have published dozens of papers on such situations to try to explain these very energetic explosions, flares, eruptions, mergers, whatever happens in such situations. So GRBs, gamma ray bursts, as their name indicates, are bursts. They are sudden explosions. I refer to them when I describe them to the students and to the general public as the biggest explosion since the Big Bang. So that gives you an idea. We are talking about explosions that produce in a few seconds and sometimes in a few minutes, but sometimes even a fraction of a second, as much as the sun, for example, will have produced in its entire life, which is 10 billion years. And then you realize there are jets. These don't explode in all directions, they explode in jets. And only when the jet is facing us, then we receive that energy, which is completely focused and concentrated in like a laser beam. Imagine a laser beam that is billions and billions and billions of times more powerful than what we produce in the most powerful lasers.
James Webb Space Telescope is revealing galaxies that are changing our cosmic timelines. Could they reshape the Big Bang model?
Until now, we thought galaxies take hundreds of millions of years to form and evolve until we are able to see them as we have seen them with telescopes until now. But the James Webb Telescope is special because it observes in the infrared, which means it observes very far away and very early emissions, and it seems to have discovered some galaxies that are not supposed to be the way we understand cosmology until now. So there is something, not the actual Big Bang of the explosion, the first few minutes, that's not being rediscussed or reconsidered by the James Webb Space Telescope, although there's another issue that I'll get to in a minute. from cosmology, but at least this observation of the galaxies is telling us that the early evolution of the universe requires some rethinking and reconceptualization, maybe remodeling. We don't seem to have modeled the galaxy formation and evolution properly enough. Fine-tuning is the fact that we have found that the universe has parameters such as, for example, why is the mass of the electron what it is? Why does the proton have whatever charge it has? Why is the speed of light what it is? Why did the universe expand as it has expanded, with whatever expansion? And so on. A number of parameters. We have found that if those parameters had been changed by even a few percent, just a little bit, change the charge of the electron a little bit, change the mass of the electron a little bit, change the speed of light a little bit, change the law of gravity, change whatever. All of the parameters that make up the universe as we know it, if we change it just a little bit, then there will be no planets, there will be no stars, there will be no organism, no life, no chemistry, no nothing like that. And so our universe is finely tuned.
Your book, Islam's Quantum Question, explores the relationship between science and Islamic thought.
I said, okay. So after many years, I sat down and I tried to sort of produce an easier version. It's not the same book. It's not a summary. It's not another version of it. It is a different book that is presented to young Muslims. And what it does is, first of all, it spends several chapters explaining science as simply as possible. So I have a short chapter on brief history of science. And then I have a short chapter on what everyone must know from science. So the shorter book, The Young Muslim's Guide to Modern Science, tries to, at the same time, present a very good, simple perspective on science.
You have criticized scientific miracles in Quran, like embryology and astronomy. Why do you oppose this approach?
So, the first reason why I reject this claim is because if you read the verses carefully, you do not find information, clear information that is scientific and was discovered only in the 20th century. Number two, I tell them, but do you think the Quran really wanted to put, that God wanted to put in the Quran scientific information that could be only discovered in the 20th century? What about all the Muslims who lived all the 14 centuries before? Do you think the Quran really wants people to find scientific information in the Quran? And how many people would be able to read those verses and understand that there is scientific information? So you're talking about 1 to 5% of the human population. Most people don't understand any of this science, don't understand any of this evidence. And the objective, the goal of the Quran is not to point us to scientific information. It is to point us to God. It is telling us, look at nature. Our sacred book, the Quran, is full hundreds of verses that talk about the cosmos and nature. But if you read it carefully, it is not trying to tell you scientific information. It is trying to tell you, look how God is great. Look how you should recognize God. Look how you should really worship God. It is pushing us toward God, not toward those scientific phenomena or that scientific information. So when I point to something like this, when I say, okay, look over there, don't look at my finger, look at where I am trying to point. And so the Quran is trying to point toward God, not trying to point toward the stars or the planets or the embryo or anything like that. That's the way to understand the Quran, much greater, much larger, as a guidance toward God.
In your book, The Story of the Universe, Make Cosmology Accessible. What's one cosmic fact that still blows your mind?
Now, one fascinating fact is the universe is absolutely huge. Absolutely huge. Means a million, billion kilometers. Our Earth altogether, the whole round circumference of the Earth, at the equator, the largest distance you can travel on Earth is 40,000. This is not even the size of a grain of dust if you compare it to a million, billion kilometers. And the Earth only was formed a few billion years ago, meaning at least 9 billion years after the Big Bang. So we are very tiny and we are very recent. We are very young compared to the whole history of the universe. And yet we are extremely important. Why is Earth and humanity extremely important even though we are very tiny and very young, very recent? Because we are made of very special matter. We are made of carbon, hydrogen, oxygen, nitrogen, which makes up less than 1% of 1%. 1% of 1% of the matter in the universe is made of this carbon, oxygen. We are very rare. We are very special. So you find this carbon, nitrogen, oxygen. First of all, very rare in the universe. We are made of the rarest material, matter. And two, we are complex molecules, very complex molecules. This DNA and the complex molecules that we are made of and that makes the world around us is extremely special and rare. So at the same time, this cosmos is huge and old, 13.8 billion years. And at the same time, we are small and young, but we are very special. We are made of the best and most special matter, atoms and molecules, complex molecules. And we have life, we have mind, we have spirit. It's extraordinary how we can be extremely small, but we are extremely important in the universe.